to the construction BM as indicated in our brochure here. I believe all of you saw it this morning, and I hope that everybody is, yeah, here it is. Okay, so today is a 4/11, so construction, and I apologize that last week I was not available, and I will do my best to come up with additional session to make up this session. Again, normally I refer to my books because those are the only materials that I use, or this is the material that I'm using, not the only, not necessarily to be the only, but the material that I'm using for my construction reference manual. And there's another book called AMBM, Problems, Solutions in Construction. I did my best when they came up with the construction way back in 2008. I came up with these books and I keep modifying them and updating them. And I hope that they will help you, like helping thousands of engineers before since 2008. I emailed you this morning this mini exam, like I did with the other discipline or other classes. So I hope that you get a chance to print it out, and I hope that okay, just to make sure that the recording is working. Yes, because I stopped it during the. Okay, so the construction BM. Also, I have about 25 problems. Some of them they are related to topics already. I talked about it in the AM, but in more depth, and this is the case for all discipline. Sorry, the allergy is bothering me a little bit. So if you look to the first problem here, problem number 1, you will find that a small section of a 2-lane highway will be reconstructed due to a flooding damage. The following table shows cut and fill areas. Testing of the soil that will be used has the following. We have a swell percent and shrinkage percent. And he gave you the stations and the fill area and the cut area. Again, units are very, very tricky in many problems, so we need to pay attention to units. And also we need to pay attention to 2 important figures. I call them figures because I put them in my books as figures. So this is 1 and this is construction BM. And today is 3, not 3, I don't know why I insist is March, 4/11/2020. So the 2 figures I need you to be aware of. One is related to earthwork calculations. Earthwork calculations. And one due to the concrete mix design calculations. Concrete mix design calculations. And they came up with these figures, okay, way back in 1995 when I was writing some chapters for Lindbergh for BPI before they sell their business to Kaplan. The Serem book, and these figures are relating some parameters if we're talking about earth work. So you will see there are 3 oval like this, and also for the concrete mix design there are 3 ovals like this. And here we call it bank cubic yard, and this is loose cubic yard, and this is compacted cubic yard, CCY. And you will see these definitions shortly. I can show to them in my books, but they are available everywhere. I can explain them. I need you to know how can we convert it from one to another. Bank cubic yard, this is the material as exists before disturbance or before excavation, as God created, or in place, or in situ, as we call it. The loose cubic yard, this after we perform the excavation, disturb the soil, and we start to load it in trucks or move it, it is in loose condition. And compacted cubic yard, this is after we place the soil and compacted to the proper compaction. And this, by the way, this is the finished product. Finished product. Compacted cubic yard. In order to move from here to here, we have a factor is called the swell factor. Swell factor. And the swell factor is different from a swell percent. And the problem statement, he gave you the swell percent. Here it is, percent, 18%, for example. So this is a percent. A swell factor is 1 plus a swell percent. And the swell factor is always greater than 1. So far, so good. The relationship between the bank cubic yard and compacted cubic yard, shrinkage percent. Shrinkage factor, which is 1 minus a shrinkage percent. I said shrinkage percent, no, shrinkage factor was 1 minus. So the swell factor is a factor greater than 1. Shrinkage factor, which is 1 minus shrinkage percent, you will find that shrinkage factor is less than 1 for most of the soils, but greater than 1 for one case, which is rocks. Greater than 1 for rocks only. And less than 1 for sand, clay, silt, name it, or mixture of these. Less than 1. And this is why here we can write some relationships. What can we do? Or what can we write? We say that loose cubic yard, LCY, is equal bank cubic yard times the swell factor. SWELL, swell factor. And the compacted cubic yard, CCY, is equal to the BCY times the shrinkage factor. Those are the two important relationships that we're going to use, and the other relationships are given in my books and in any other book available in the market. But we need to know the relationship between them. There is no relationship between this and this, by the way. You cannot convert it from LCY to CCY, no. You have to do this. And we're going to see this shortly in the problem we're going to solve. So two relationships, the loose cubic yard and compacted cubic yard. The similar, or in analogy to this, the concrete mix calculations. We have here what is known as SSD. SSD here is not the stopping side distance we are using for transportation. SSD to indicate the stopping side distance. But here for mixed design, no. This is saturated and surface dry condition. SSD means saturated and surface the dry condition. Below the SSD is the dry condition, either air dry or oven dry. Above the SSD is the wet or moist. Wet. From here to here, in order to change the status of the aggregates, the fine and the coarse, from the dry condition, either air or oven dry, to saturated surface dry condition, we are going to multiply it by the SSD moisture content. Moisture percent or content. Percentage is fine. From here to here, from dry to wet, we call it moisture content. Content, which is also percentage. The SSD moisture content must be given to you, by the way. Must be provided in the problem statement if it is needed. And the moisture content also could be provided, or you can calculate it. Because the moisture content which is normally we use lowercase w. Most of the books and most of the NCEES publication, they are using that, which is equal what? Is equal the weight of the water, how much water in the soil, over the weight of the solids. And we multiply by 100 to get it percent. This is a definition for the moisture content. So these two, I needed to be aware of the concrete mix design calculations and the earthwork calculations. If we remember these two diagrams or these two figures, I believe it can make a huge difference during the exam, where you have, because sometimes there is no time to locate whatever you are looking for, but do your best, and if these things you can remember them, try to remember them. And we are going to see the application for both. In fact, if you look to the concrete mix design problem, I believe the NCEES, again, we have books for construction, like books for the transportation, geotechnical, and so on. So if you look to the construction PM, let me see if I can locate one problem. If I have the book handy. If not, I can get it very quick. And it does have a problem related to the concrete mix design, and they have this keyword, the one I just mentioned a few minutes ago, or a few seconds ago, in fact, not a few minutes. Here it is. Let me see if I can find it in 22 seconds. That's good news. If not, I will tell you, sorry, here it is. This is the construction BM, the blue book. This is a problem 529. If you have the blue book, the NCEES, this famous blue book, I call it the blue book. If you read this problem, if you have it handy, that's good. If not, I may include it with a concrete mix design for a highway project requires 590 pounds per cubic feet of cement. On a weight basis, the mix design has the following proportions: 1 to 2.25 to 3.25. The aggregates are SSD. Here we go, SSD, saturated and surface dry condition. He's telling me that the aggregates, both fine aggregate, which is sand, and coarse aggregate, which is a gravel, both of them are at the SSD condition. The statement here in the problem is good news for me. Why? He's telling me that both the fine and the coarse are at the SSD condition. SSD condition, we call it saturated and surface dry, as I mentioned here. That means that the aggregates will not give or take water. Self-sufficient. Self-sufficient. Saturated, that means that it will not absorb water. And the surface is dry, so it will not give. This is what is meant. This piece of aggregate, here it is. I have a piece of aggregate. You cannot believe it. Probably you heard this before. But this piece of aggregate came from New Mexico when I was doing over there my PhD. Way back, my master and my PhD over there in New Mexico State, in Las Cruces, New Mexico, next to El Paso, Texas. And when I came to Fresno, California, I carried this piece of aggregate from the lab where I was teaching. So it's a long history. So it is this piece of aggregate. This is a coarse aggregate, crushed coarse aggregate, not natural, crushed, as you can see. And it does have, if it is SSD, that means self-sufficient, will not give, and it will not take, will not give, will not give, will not absorb. This is what is meant by SSD. Okay, and this is the ideal condition. So in the problem statement, he told you it is SD. This is a gift. That means that there is no adjustment for surface water. Because adjustment for surface water is one of the things that I needed to adjustment for surface water. And sometimes is it tricky, and I have a lot of problems, tons of problems. Many of them since from New Mexico State when I was teaching these classes, materials and concrete and all these things. So he said that the specific gravity for both of them 2.65 for both and fine, and the specific gravity for cement 3.15. The water cement ratio is most nearly. Do you remember this morning I was talking about that 1 gallon of water is equal what? How many pounds? 8.34 pounds. And 1 cubic foot of water, it does have 7.48 gallons. Try to remember these two numbers, and they are mentioned at the beginning of each book for units and so on. He is asking what is the water cement ratio. Water cement ratio, it could be a decimal like this. Here it is, point something, or it could be whatever the numbers, or it could be how many gallons of water per 1 sack of cement. It's still the ratio by weight, by the way, because the water cement ratio is the ratio by weight. How many pounds of water, how many pounds of cement. This also the ratio of by weight, because gallons of water, how many gallons? And we know each gallon has 8.34 pounds, and I know 1 sack of cement is 94 pounds, as you know. Each sack of cement, 94 pounds. And they made it 94 because this is the volume of 1 cubic foot. They didn't make it 100. It's 94 pounds. Good. A sack of cement is 1 cubic foot or 1 cubic feet volume. So it weighs 94 pounds, not 100 pounds. I need you to remember that. Or 50 pounds, as sometimes we think that a sack of cement weighs 100 pounds, and sometimes we think that it weighs 50 pounds. No, neither. So in this case, the water cement ratio could be either a decimal like this, but it's still this ratio by weight. It must be by weight. Must be by weight, not by volume, never. He gave you the specific gravity of the cement. As you know, all of you know that cement, we have 5 types of cement. Cement, we have type 1, type 2, type 3, type 4, and type 5. These 5 types of cement, we use a specific gravity. We write it like this, or some book they write it like this, GS. It is 3.15 for all types of cement, irrespective to what type of cement. They calculated and it came out 3.15. So by default, this is the default one. Unless in the problem statement he gave you 3.14, 3.12, 3, whatever. If it's not given, we take it as a default by 3 as a 3.15. Specific gravity is G or GS. For type 1 cement, this is the general, for general purposes, where no special requirements are required. Type 2, we use it for low heat of hydration, low heat, and low sulfate resistance. Sulfate, F or pH? SCU, pH or S, okay. This is high early strength. High early strength. Type 3, which we call it fast setting. Fast setting. Fast setting. Type 4, hopefully I can squeeze all of them here. Type 4 is high heat of hydration. High heat of hydration. When we have a high heat of hydration, it will be generated, and I will define what's the hydration in just a minute. Like when they build Hoover Dam, I will tell you the story about the Hoover Dam. And finally, type 5 high sulfate, SLU, sulfate, SLFUAT, high sulfate, SAL, SUL, no, I was right, SULFATE, sulfate, sorry, sulfate resistance. High sulfate, SULFATE or SCULULBHATE. Okay, sulfate this way or this way. I prefer with F. I believe the British, they write it that way, sulfate. So irrespective of what type of cement you are dealing with, we are going to get only one, or we have one specific gravity. Hydration, by the way, the word hydration This is a term that you heard it many times before. This is a chemical reaction between water and cement. And when this chemical reaction is happening, there will be a heat. It's called heat of hydration. And the heat is the biggest enemy for concrete where it's still fresh. So we are using type 4 for low heat of hydration to, okay, for high heat of hydration type 4 to reduce the temperature, to reduce this. The chemical reaction will happen, but with minimum heat, because the heat is going to create cracks. And this is what happened when they built the Hoover Dam. Those who went to Hoover Dam and you watch the movie, they have about 15-minute movie, black and white, obviously. This was during the Great Depression in 1929. They were talking about this yesterday, by the way, when they are comparing the coronavirus impact, the COVID-19 impact on the economy, and the 1929 Great Depression. Are they similar, not similar? And I hope that it will not be the case, because right now we have about 17 million filed for unemployment. When during the lunch I went home and I watched the news, and unfortunately the lines are too long for getting boxes of food, like the organization feedingamerica.org, the one I decided to contribute money to them, because there really is a crisis. All of us will have to work together. It was in 60 Minutes, by the way. Last Sunday, I was watching 60 Minutes on CBS, and I found what amazing families over there in New York. They are sharing, they are working, instead of family working 40 hours a week. They said, no, we are going to work only 20 hours and give the another family 20 hours. So they share the paycheck, which is really, this is, we have to do that. So do your best, and I will do my best. So the Hoover Dam, when it was built, okay, in during the Great Depression, and that moment they don't have this type of cement. So in order to reduce the heat, because the Hoover Dam is a massive concrete dam, and they are dumping millions of cubic yards of concrete, or thousands per cubic yards of concrete every day, whatever call it, okay, but the total millions. So because of the heat, and they would like to finish it so fast, so they were using ice. They replaced the water with ice to replace the water. And this is what they did. They built ice factory next to the site where the Hoover High Dam was. This is shown on the movie, by the way. If you go to the movie, you will see that they built a factory to produce ice, so they can replace it with, put the ice instead of the water to reduce the heat. Because at that moment, this kind of cement was not available at that time. And now, so the heat of hydration is an issue, and we need to be aware of that. So going back to the problem I was talking about, and I will go back again to the earthwork calculations. So the specific gravity 3.15, I need you to remember that. Specific gravity for coarse and fine, for coarse and fine aggregates, they are different. They are not always constant, but in this neighborhood, 2.6, 2.65. Here, this is 590 pounds per cubic yard. This is the cement. They added cement, excuse me, at this rate. And they mention another number in the problem, which is 1 to 2.5 to 3.25. This is 2.25. Sorry, I need to see the other two here. 2.2. What does it mean? Okay. Mixing concrete mixing, there are two systems. the ratio, and the ratio could be either by weight or by volume. By weight is the most common one. This is the most common. The second approach, instead of the ratio, we're using the absolute volume equation. Absolute volume. And the absolute volume equation says the volume is equal the weight over gamma water times the specific gravity, SG. Very important equation. I need you to be aware of this equation. Let me write it down here. So concrete mixing mixing. Oops, sorry. Let's get something fancy here. Concrete mixing as I said, that it could be by ratio or by the absolute volume. The ratio, it could be by weight or by volume. I said this is the most common one. The absolute volume, the volume is equal to the weight. At least when I scan these things, you will get it, weight divided by gamma water times specific gravity. And this is a more accurate one. The ratio, like similar to the problem we have, 1 to 2.25 to 3.25. What does it mean, these numbers? These are the ratios of what? The first part of the cement. Always one is the cement. This is what my grandfather and your grandfather, this is a method that what was used way back by your grandfather and my grandfather. So let us respect them and let us keep, okay, honoring them by keeping the same ratio as they agreed upon. The second one is 2.25. This is the sand. The third one is gravel or the fine aggregate. Gravel, the coarse aggregate, gravel, coarse aggregate, and this is a fine aggregate. This is the ratio that my grandfather and your grandfather agreed upon, and as I said, we are going to respect that and we are going to honor them, not to change these things. So let me grab a question, I believe, or maybe a correction or an advice, or let me grab this. The question is, did I say anything? Fine aggregate, coarse aggregate. Okay. Fine aggregate, coarse aggregate, this is sand and the gravel and so on. Yes. Okay, probably sometimes I use abbreviations. You are very welcome to quit. So going back to this problem, which we can solve it together. And I need you to remember this equation. This equation is so powerful. This one here. the absolute volume equation. And this equation, by the way, is not strange. This equation, we know it. Because what is a specific gravity? What is G or GS? Whatever. GS is the ratio between two things. Specific gravity of the material is a ratio between two things. Excuse me. The ratio of gamma material over gamma water. This is why, what is the specific gravity of water? Of water is 1. Because basically it is a gamma water over gamma water is 1. But any material that will sink in the water, specific gravity greater than 1, like our aggregate 2.65, any material will sink. Here it is. This is the water here. This is the surface of the water. So any material that will sink here, it has a specific gravity greater than 1. Water, it has a specific gravity of 1. Anything that will float on the surface of the water, it has a specific gravity less than 1. It will float, okay? And this is specific gravity is equal 1. This is the water. And this greater than 1, any material, like piece of aggregate. If I throw this piece of aggregate in a cup of water or in a bucket of water, it will sink. Why? Because it has more specific gravity. Simple like that. Greater than 1. Like our aggregate 2.65, the one given in the problem here. And this is amazing, by the way, because during winter, when the water freezes, I was in Colorado in November 28th. I will never forget that. Last November, I went to Colorado to visit my daughter over there. She's doing her PhD at UC Boulder. And I went to a place, oh my God, it was very cold. Anyhow, when we have an ice, the ice will be forming, it will float. Even the ice is made of water, but the ice has a specific gravity less than 1. And this is why the ice floats on top of the lake, because we have fish here and we have living organisms here, or fish. And if the ice will sink, it will kill all this, okay, habitat, okay, in the water. This is why the ice will float, because the ice has a density, it has a specific gravity less than 1. Let me put that. And density less than water, obviously. Okay. Anyhow, so this equation is not strange. The absolute volume, you can derive it even if you forget it. You can say, oh, wait a second. I remember from physics in school that the specific gravity is equal to gamma material, whatever the material is, over gamma water. But what is gamma? Gamma is weight over volume. Weight over volume. And this is gamma water. I can solve for the volume. So the volume is equal weight, W, or weight, here it is, weight, which is W, divided by gamma water times the specific gravity. And this is the equation that I needed to remember, absolute volume equation. Absolute volume equation. And this is, you are going to use it a lot for concrete, either in the AM or in the BM. They could have a very simple problem in the AM, but for construction group, they should master this subject. And I cover it very well in my book, and I have a chapter talking about that. So if I know the ratio, it is 1 to 2.25 to 3.25. So I have this cement. He told me that there is 590 pound per cubic yard of cement was added. This is a portion of the cement. Can I get the fine aggregate? Yes. I say the weight of the fine aggregate, weight of the fine aggregate is equal what? Is equal 590 times 2.25. Is this correct? Yes, the ratio. He told me that. So if you multiply the 590 that's given, 590, enter, 2.25 times is equal 1327.5 pounds. This is the weight. Can I get the volume of the fine aggregate? Yes, I will take the weight 1327.5 using this equation. Here it is. Divided by what? Gamma water. What's gamma water? Do you remember this morning? 62.4 times. Specific gravity is given in the problem statement as 2.65. So it is 2.65. This will give me cubic feet per 1 cubic yard. Because here 590 per cubic yard. Everything based on 1 cubic yard, by the way. For concrete mixing, we are assuming that we have 1 cubic yard. And we can proportion our mix. But it is 1 cubic yard. The unit volume that we use, 1 cubic yard. One cubic yard. So this number here, I don't know how much is this number, but here it is. 62.4 divided, 2.65 divided, it's 8.03. What about the weight of the coarse aggregate? Of the coarse aggregate, which is a gravel. He said that the ratio, here it is, coarse aggregate or the gravel at 3.25. So I will take the 590 pound times per cubic yard times 3.25. It is 1,917.5 pounds. Pounds per cubic yard, by the way. Everything per cubic yard. Can I get the volume of the coarse aggregate is equal the same equation 1917.5 divided by 62.4, and we are lucky the same specific gravity, so it is 2.65, but it could be different. I got 11.6 cubic feet per 1 cubic yard. Can I get the volume of the cement? Yes, cement, he told me there are 590 pounds per cubic, so I will take the 590 divided by 62.4 times the specific gravity for the cement, which is 3.15. So it is 590, enter, 62.4 divided, 3.15 divided, so it's 3.00 cubic feet per 1 cubic yard. So I have 3 volumes now. I have the volume of the fine aggregate, I have the volume of the coarse aggregate, I have the volume of the cement. But how many cubic feet per 1 cubic yard, by the way? I know there is a 27 cubic feet per 1 cubic yard. Don't forget this number, please. So if I know the volume of the fine and the volume of the coarse and the volume of the cement, I can get the volume of water. because if I add all of them, this plus this plus this, subtracted from 27, or all of them, they should have to 27, this will give me the volume of the water. So it is 8.03 enter, 11.60 plus, 3 plus. So the sum here, the sum I came 22.63. I will take 27 minus, so this will give me 4.37 cubic feet per cubic yard. This is the volume of the water. He didn't mention anything about the air. I know you are going to ask me in just a second, what about the air? So in this case, can I get, since I know the volume, I can get the weight, opposite what I did. So the weight of the water is equal this volume, which is 4.37 times 1 times 62.4. This will give you what? What is this one here? This specific gravity for water, the one I mentioned. So it is 62.4 times. So this is, it is 272.69 pounds of water per cubic yard. Now I am almost done. I'm a little bit slow, but during the exam you will be way faster than me. Now we need to get the water cement ratio. The water cement ratio, it must be the ratio by weight, not by volume. Water cement ratio. Do I know the weight of the water? Yes, here it is. It is 272.69 pound per cubic yard. And I know, and the problem is it 590.00. If you like to say pound per cubic yard, I have no problem. Pound per cubic yard, because water cement ratio is a dimensionless. So if you divide these two numbers, we get a number. Hopefully that we'll have a number among the 4 answers to match. So it is 272.69 enter, 590 divided, I got 0.4622. And in the problem statement, we have 0.37, 0.46, 0.54. Obviously 0.46 is my, is this correct? Yeah, 0.46 is the closest one, or the one they call it most nearly. And I hope this is the answer. For those of you who have the book, you can look to the answer and see if this is correct. Otherwise, if I did a mistake, I will be glad to correct my mistake immediately. Makes sense? Easy stuff? Any question about this? This is without any adjustment for surface water. This is a very easy problem. In fact, the moment that he's telling you or telling us that the aggregates are in the SSD, I call this as a gift. Because the adjustment for surface water, I will cover it. I will cover it because I need you to be aware of that, because this is very easy problem. Very easy. I know it is a 6-minute problem, but obviously, as you can see, I'm not solving the problem because I could solve it, and here it is. No, I need you to understand the concept. And if you understand the concept, it doesn't matter what type of problem they will give you in the exam, because exams are not easy and they give you some tricky problems, but if you understand the concept, it does not make any difference. If the problem is tricky or not tricky, you are going to ace it. And this coming October exam, I hope that this things will improve, as I mentioned before, and I hope that the October exam will be the exam. I believe it's coming October what? October 20 something. Here it is, October 23rd. Yeah, so this is the 3rd week, okay, of October 2020. I hope by October everything is clear where we can have the exams again. And because it will be a disaster if you are going to postpone it again until January. I hope not. I hope not. I hope this pandemic will be gone, or this corona will be gone. Okay. So all this was triggered by the first problem, which I didn't solve it yet. Oh my God. This here. The first problem, which, as I told you, that we do have the 3 volumes, the bank cubic yard, loose cubic yard, compacted cubic yard. Try to write as much as you can while you are studying. Try to draw sketches, diagrams, as I mentioned before. And forgive me because I'm repeating myself a lot, and I said from here to here is the swell factor, and from here to here is the shrinkage factor. So here he gave you the area in square yard, and the station, it is in feet. Station 4344, the distance from here to here is 100 feet. Don't forget units. Here it is. The killer, the common mistake. So the question. So given, we should understand all the given information. Find what? Find the excess soil that will be held outside the project limits. Any project, if this is the OG, the original ground, and we have Euro profile grade, something like that. We call it a profile grade PG. This is a vertical alignment. Vertical alignment. So as you can see here, we have portion under the OG. So this is cut. And a portion of the profile is above, so this is fill. And finally, this is a cut, C. We're using C for cut and F for fill. This, when we are crossing here, is very important, by the way. Crossing, when you are crossing, transitioning from cut to fill is very important. And is very important in what sense? In what application? In the mass diagram. So don't worry, I will solve the problem before we go tonight. Because every time I hit a topic, I need. This is, it could be a question, by the way. This line here is not, this is not good line, okay? This is a crooked line, okay? No. So yeah. Engineers, okay, we have to draw good lines, okay? So the reason I'm doing that, and let me make the original ground a little bit dark. At least you can see it. There, I mentioned something about, what did I mention? Oh, about, I can't remember what I mentioned. Oh, the transition points. Okay, yes. They are very, very, point number 1 and point number 2. I will ask you to sketch me the mass diagram. I will draw the horizontal and the vertical. Already I draw it. Can you sketch me the mass diagram for this hypothetical? As you know, the mass diagram is a graphical representation of the cut and the fill. And here it is. So this is 0 and the y-axis. This is cut, which is a plus, and this is fill, which is a minus. And the x-axis, or the abscissa, we call it station, which is a distance. Let me give you 2 minutes to sketch me the mass diagram. I am looking for the mass diagram. On the exam, it might give you a scenario like this. I'll give you 4 mass diagrams and tell you which mass diagram is the one representing the given scenario. This is given. And the 4 mass diagrams would be to match the mass diagram that's correctly described the given condition. Let me throw this problem and let us take about 10 minutes break. Okay, right now is about 2:05. So 2:15 we'll come back and they will work it together and see what mass diagram you came up with. It's a very good. So right now is 2:05, 2:15. Thank you very much. So the mass diagram is the relationship between two parameters, the x and y, and probably we talked in the class about two mass diagrams given in the NCEES, probably in the class. I don't know if I covered them or not. 504 is this for the construction BM, a mass diagram problem. And in the following page, there is a mass diagram problem also given, another mass diagram problem. So a mass diagram, it could be a target for a question. So let us be ready for that, just in case. And if you understand the concept of the mass diagram, it doesn't matter which, as I told you, which problem they are going to give you, but the concept is going to help you to understand. Here we have cut, because the profile or the vertical profile grade BG is below the original graph, so I have a cut up to this point. A cut means positive quantity, and it is positive slope also. So they agreed, and we could draw it as a curve or as a straight line. It could be a straight line or a curve. Okay, let's assume that I will draw it as a straight line first, or a curve. Let me draw. So the curve will start from 0, and every one station I'm going to add volume and volume and volume and volume and volume and volume and volume until I come to the maximum. So this is a positive slope, which means cut. And this volume here, by the way, this volume here is not the absolute volume. It must be the cumulative. Cumulative means additive. I'm here right now, and this is the key point, as I told you. I'm transitioning from cut to fill. The slope will change. I will come down. Let me make it a little bit flatter because it's very steep. I will come down. This is the fill. It will come down. Up to here. Why I went down a little bit and still a lot of cut? Because this amount of fill is way smaller than this. And so this is negative slope, which is fill. Another key point, transitioning from fill to cut, the slope will come back again to positive. So I start to come positive again. Like the problem given, it's changing from cut to fill, positive, negative, and so on. We need to be aware of that. So here it is. And as you can see, we ended with higher cut. Because if you look to this cut and this cut, it's more than fill. So here, this is cut way greater than fill. We have excess. And this is a mass diagram. This is how much soil available for me to hold it out. Because we have cut more than fill. The soil that will be generated from the cut sections of the roadway, this is maybe resemble this what is given here. But I needed to be aware of that. And this, by the way, this is high point. A high point is a transitioning from cut to fill. Low point, this is start to cut again. A low point, this is a low point. A low point on a mass diagram transitioning from fill to cut. Here it is. So going back to the problem, I'm not going to do anything until I finish the problem, any other problems until I finish this, because I know it, you are so eager to see this problem. So the excess soil, the excess will be in what? Will be in loose cubic yard. That has to be hauled. When we haul it outside, when we haul it in a truck, or when we have an excavator like this, okay, or sorry, loaders, to load it into the truck, it will be loose. So when the material hauled in a truck is going to be, or if it is a dozer is pushing it, okay, where is my dozer? Here it is. My dozer, here it is. Pushing it, it will be loose. So you need to know that. So we need to get the volumes. And as you know, the volume computations, very important also for construction. Volume computations. We have the average in the area. In the area method, which is the most common one. It has some problems, but it's not a big deal. We can talk about it. Prismodial. A prism or pyramid, which is a 1/3 rule, as we call it, 1/3 the area of the base times L. This will give you the volume. The volume here for the prismodial, it is L over 6 of A1 plus 4AM plus A2. And the volume here is equal A1 plus A2 divided by 2 times L. The 27 is just to convert, but this is a general. So if the problem statement doesn't say anything about the volume or the method that to be used for computing the volume, normally we go with the average in the area method. Normally, this is the first one, which is average in the area method, as we're going to see shortly. But there is another thing that I needed to be aware of, which something is called truncated cone. Truncated cone method. And this is very, very interesting equation. And so this is method number 1. I was looking for something here. Okay, method number 1. Number 2, Prismodial. Number 3. And number 4 is the truncated cone. Truncated cone. And there is a number 5, which is a Boro bit volume. Boro bit method, like the problem in the NCEES, problem number, I think, the second problem 502, is asking Boro bit excavation. And all of them, by the way, if you I remember the basic equation for the volume computation in school, you will find that all of them, they are based on one simple equation, which is what is the volume? The volume is equal to the area times length. This is the equation that we learn in school, and it's still the same equation. Still the same equation. I'm looking for something here very quick. Probably I'm not able to see it. Okay, so the volume, either this or this or this, you have to decide very quickly during the exam which method should be selected or should be used. So the problem that's given, I have station 43 and 44. I have area of fill, so I can say the volume of the fill is equal to 0 plus 62.4 divided by 2 to get the average in the area, time the length is 100 feet. Remember, this is square yard, so I have to divide by 3 here to convert it from feet to yard, plus the second one, which is 62.4 plus 98.4 divided by 2, and again it is 100 feet divided by 3. This is the volume of the fill. In this case, it will come cubic yard. Because this is square yard. 62.4, no, 64.2. It seems that I put the water density of water blindly. 62.4, forgive me for that. So if you calculate the volume for this, you will find that it is 64.2, enter 0.5 times 100 times 3 divided, and the other one 60, again 64.2, 64.2, enter 98.4 plus 0.5 times 100 times 3 divided, and the plus, this will give us 3780. This is the volume of the fill. I will repeat the same thing for the volume of the cut. And this is 66.7 plus 147.4 divided by 2 times 100 divided by 3 plus 147.4 plus 0 divided by 2 times 100 divided by 3. So 66.7, enter 147.40 plus 0.5 times 100 times 3 divided. Okay. And the 147.4, 0.5 times 100 times 3 divided, and the plus, this gives us 6025.0 cubic yards. So this is the first step I will do. I will calculate the volume of the cut and the volume of the fill using the average in the area method. And you might say, oh, we have a zero area here. Why didn't you use the 1/3 rule? Now, the 1/3 rule, which I will talk about this later on, this here, which is 1/3 area of the base times L, 1/3 the area of the base times the length or the depth. It used only if we have a true prism. But this given scenario, by the way, is like this. You have an area. This is a roadway, like a wedge, like this. So, for example, this is station 43 plus 00 for the fill, for example, and the station 44 plus 00, I have an area of the fill. This area here is equal 0. So this area here is, this area here is given to me, for example, the 64.2 square yard. So we cannot use the 1/3 rule. The 1/3 rule, we use it only if this is the case. Let me draw a similar scenario, similar area here, that this area exists. It is 64.2 cube square yard, sorry. And if this area at the end here, a zero area but forming a true prism. So this area is equal 0. This here I use the 1/3 rule. 1/3 rule of the 64.2 time the distance, assuming this is still stations, the same. This is station 43 plus 00, and this is 44.00. You see the difference between them? This, in this case, I would say 100 divided by 3. But here we are forming a true prism or a true pyramid. But this is no, this area here like a ramp, okay, like a ramp for freeways or something like that. So this here, you have to use the average in the area. This is called the wedge method. Wedge method, which you're using the volume is equal A1, and this is A2, A2, A1 plus A2 divided by 2 times L. Here I'm using the 1/3 rule, which is a 1/3 area of the base times L. So there is a huge difference between them. Anyhow, we got two volumes now. And here is a fun stuff. So I have volume of cut and volume of fill. Okay. So the volume of fill is given to be 3780 cubic yard, and the volume of cut is 6025 cubic yard. So far, so good. As you can see here, the cut is greater than fill. So we have excess, or sometimes we call it waste. That means that we have to hold the excess material out. And this is what he's asking for. What is the excess? But I cannot really take the difference directly like this, because I have here bank cubic yard, loose cubic yard, and this is the compacted cubic yard. This is the fill. Which I know this volume here is 3780, because we put the volume of the fill after compaction after it's done. The volume of the cut is cutting it from the bank cubic yard. So I know the volume of the cut here is equal to 6025 cubic yard. And he's telling me how much excess soil has to hold out, or has to be hauled out to haul it and dump it somewhere or store it somewhere. But when we hold it in a loose cubic yard, loose state. So I have to convert it from one to another. And we know the conversion from here to here is the swell factor. And from here to here is the shrinkage factor. And here are the benefits of the diagrams now. You see that? I hope that all of you are following me, and because this is very, very important. And they're so tricky. Sometimes they are so tricky on the exam. So we need to convert one to another. He gave me two percentages. The swell percent, which is 18%, and the shrinkage percent, which is 10%. These percentages are given. So it is easier for me to convert this to this, to make it the same as the cut, and take the difference, and after that I will convert the cut into the loose. This is a way I will recommend. So I have, compacted cubic yard is equal to bank cubic yard times the 1 minus shrinkage percent, which is a shrinkage factor. So I need to get what will be the bank cubic yard equivalent to this. So the bank cubic yard, BCY, is equal compacted cubic yard divided by 1 minus shrinkage percent. I have 3780 divided by 1 minus the shrinkage percent is 10%. So this is 3780.9 divided 4200 cubic yard. So I convert this to this. Right now I can subtract this from this because this orange and this orange. This it was orange and this is banana. I cannot really subtract them. I have to, so this is orange and this orange. So right now I say delta cut, delta volume of the cut is equal what? Is equal to 6025 minus 4200 cubic yard. Obviously this cubic yard too. So this will give you what? Will give you 6025 minus, will give you 1825 cubic yard. But this volume of the cut here, he's asking how much volume will be hold out. It must be loose. So I said loose cubic yard is equal bank cubic yard times 1 plus swell percent. So I will take the volume I just calculated, which is 1825 times 1 plus, what is the swell percent? 18%. If you do that, you'll get a number. It is 2153.5 yard. And this is the number that he is looking for. In fact, you will find all the numbers we got. We have a number 1825. We have this, and we have this, and we have all the numbers. But the correct number is 2153 point. So 21.4, and the answer is B, as in boy. And all the numbers are intermediate numbers. The 3780, here it is. The 6025, here it is. The difference, even the difference, 1825, he give it to you as an answer A. He give you all the answers that to match any number that we are using as intermediate step in order to get the right answer. Any question about that? So the answer for this is B as in boy. Any question about that? I need you to solve it, and when you receive my notes, look at it. If you find a typo or a mistake or an error, please let me know. But we need to solve all these problems are really, really good. Are really, really good. You try to do all your best to solve all these problems. Some of them already I solved it once here in the class, maybe, and some of them are not. But I need you to really doing your best in order to understand the concept and very good problems. So when I started way back 30 years ago, okay, I have thousands of problems from school where I was teaching, and okay. So let me grab a question and follow. Can I see your note? Cannot see. What can you cannot see my notes? Why? Because of what? Because of the camera, or because the speed, or what? Let me probably the camera is not completely full screen, probably. Let me get the full screen. I don't know why the camera is not. Here we go. What about that, my friend? This is the maximum I can get. Okay, and here we go. And you'll get these notes. I know probably I'm writing so fast, but try to cover as much as I can. Okay, so I try to look to these things, and I will be glad to answer any question. Okay, and even I can reduce it a little bit here. You can see more, and here it is. It will be smaller, but you can see the entire page. Okay. Okay, here we go, my friend. So let us do our best. And again, I need you to work it in your own. I show it to you. Even if you miss something from my notes, you will get it. I will scan it and send it to you. I need you to challenge yourself by going over these problems and try to do your best. And I will try to do my best too at the same time. So this is a problem number one. If we look to another type of problems for construction, again, construction PM, look to this problem here, which is also given, I believe, something similar to it in the NCEES. And this is something very important related to the CPM, the critical path, the CPM. And the CPM, I covered it for the AM, and we covered it for the PM in more depth. Here it is. This problem here. Okay. And he is asking what will be an activity in node network for a project is shown in this figure. All relationships are finished to start. With no lag unless otherwise noted. If all activities begin at their early start except activity E, which is delayed by 2 days from the early start, he gave you a diagram, and here is a legend. This is the NCEES, by the way. NCEES legend, where we have the activity name, whatever the name is, and the duration in days, and we have early start, early finish, late start, late finish, and we have FF and TF. This is the total float, and FF is the free float. And as you can see here in this problem, that the only lag given this problem, when they draw it for me, they are missing a little bit, just a line like this, horizontal line missing. I noticed that. And this line here also is like that. Here it is. Other than that, I believe all of them are there. Yeah, this line here and this horizontal line here. What is a lag? Lag, okay. Lag is amount of the time that an activity can be delayed, and there are 3 types of lag. I put them in my construction books. For those who have my construction books, maybe, okay, I can give you, normally I refer to this book, the AMBM, or the textbook itself. Both of them are having a good summary, and I include all these things. So if you look to, and again, this is for construction group. In my this book here, the AMBM book, the AM, which is a book number 2, construction, on page 63. Page 63, just to save time, I need to use my diagrams here, or the diagrams I'm using for lag relationships. This is an activity A or task A, and this is a task B. Those who are not taking construction, if you are interested to include this, I will be glad to make a copy and include it also. Hopefully, I will remember all these things. And this is another way to show the relationship between activities. And on the same book, on page 62, this is the NCEES format, the one you see it in front of you. This is the early start, early finish. They go vertically like this. And this is late start, late finish. This we call it forward. And this is a backward path, backward. If we are using other formats like this, they put it horizontally, where the early start, early finish, this is horizontally like this. Early start, early finish like that. This is called forward pass. The forward pass is relating early finish with the early start, early finish, okay? And the backward, which is this one here, backward, so it doesn't matter if you use this or this, as long as we know how to construct the CPM. Either vertical, this is a vertical, I call it this is a vertical, and this is a horizontal. Horizontal, a little bit easier, but vertical is not a big deal. So what is a lag? I'm using here horizontal, just to illustrate. So this is activity A and this is activity B, or task A and task B. If we delay finish to start, we call it FS lag. This will finish, and this activity or this task will not start immediately. It will wait for a few days. And I will explain this a little bit. If the lag between F and F this early finish of the task B, early finish of the task A. We call it FF lag. And the other one is called SS lag, the start for each activity, early start. Why we need to have a lag? Lag is an amount of time that an activity can be delayed in order to achieve something. Lag is called lag. Lag is a time that an activity could be delayed with respect to another activity or task, by the way, another activity or task. It's called lag. So in order to solve the problem, let me show you, and after that we will see what is the answer for this one here. Our friend, for example, he mentioned an example. We can wait for the environmental report. Yes, you could have the design, and the design is waiting until we get the environmental document. Yes, you could finish the design, but you cannot go to construction. Yeah, I have a design here. The design is done completely. Theoretically speaking, I'm supposed to go to construction, but because of the environmental document, for example, is not ready, or okay, there's some kind of public hearing or any kind of environmental requirements, I have to wait until we get the environmental. So in this case, or I put the concrete slab for a house. This is a slab for the house. And I'm supposed to have the frames, the steel frames that it will be here and start to build my house or start build a building. But for some reason, the steel frame will be delayed. There was a storm or something like that, whatever it is. Or I contact the factory and the factory said that we are really booked and we have no delivery until the beginning of June. So I can put the concrete and wait. So the early start for this will be delayed after we finish this, because the steel frame is not available yet because maybe the manufacturer is busy. So we impose some kind of time in order to achieve a certain activity completion. So going back to the problem, and let's finish it together and see how the lag, this here, this is the FF lag between C and D. If you complete this, and this is a vertical, this is vertical. Vertical means, again, he told you that. So this is going to be forward, 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 and forward. Let me use different color for the backward. A backward is like this. A backward is like this. And here it is, a backwards like this, and the forward is early finish and early start, early finish. Here it is. So this is a forward. And the other one is a backward, the color one, the orange one. So let's continue, and hopefully that you can help me catch my mistake. If I did a mistake, try to catch it, because okay, sometimes I do mistakes like anybody else, and the beauty about mistakes that we can learn from our mistakes. So if you add this to this, we add the early start to duration will give you early finish, because we know that early finish is equal early start plus duration. This one equation, we know it. So if I add 1 plus 3 will give you 4. So add this to this will give you this. And add this to this will give you this, which is 5. I will move the 4 here. So 4 plus 2 will give you 6. Here I am going to move 5. Sorry. Hold it. So there is another arrow coming from the other one. Hold it. Here it is, Mr. Mansour. Okay. Here, this activity F is controlled by this C and B. I have 5 and I have 6. When I transfer the larger, which is 6. So for the forward, it transfer the larger or the largest. Because F cannot start unless C is done and B is done. B is done after 5 days, but C needs 6 days, so it has to wait until 6 days. You see that? And this E depends on C. C is finished at the 6, when it is 6 days. 6 plus 1 is 7. And 4 plus 6 is 10. Now, this activity D in relation to activity C, if it is normal, I will move this 6 to put it here. If there is no lag. If there is no lag, but this is finish to finish. This is early start, and this is early finish. Early finish for this is 6. But there is a 3 days lag between them. So this is the early finish. That's correct, D. Okay, this is the early finish for D. So the difference between this and this must be what? Must be 9. Because 9 minus 6 will give you 3. Right now, 9 minus 2 will give you 7. And this is the trick here. So if there is no lag imposed on this, I will move the 6 and put here. 6 plus 2 will give you 8. Okay, but right now I work backward. Why backward? I said, okay, this is the early finish for activity D, and this is the early finish for activity C. The difference between them must be 3. So I took this and add the lag time to add this. This is finish to finish, lag. Are you following me? Right now, activity G, it depends on the 9 and the 7. We move what? We move the larger, 9. 9 plus 2 is 11. Activity H, it depends on this only. So this is 10. So it is 10 plus 3 will give you 13. This is the forward path. The backward path, let me use different color. 13 is still the same here. 13 minus 3 will give me 10. I will take this 10 and put it here. 10 minus 1 will give 10 minus 4, there's not 1, this 4 is 6. And I have here the activity G and the activity H. Here, the early, the late finish, this is the late finish. Late finish. This late finish of activity H will be the same late finish as activity G, which is 13. 13 minus 2 will give you 11. 11, I will move it here to be 11. Minus 1 will give me 10. And the 11, I will move it here. Minus 2 will give me 9. I'm going backward. I transfer the smallest, by the way. So right now, this activity C is controlled by D and E and F. I have 9. I have 10. And I have 6. Which one I transfer? The smallest. So for the backward, I transfer the smaller or smallest. So the 6 will be transferred here. 6 minus 2 will give you 4. And this will go here, 4 minus 3 will give you 1. And this here is controlled by 6 because it only depends on that. So 6 minus 4 will give you 2. This is the most difficult part of it. Now we have something is called the critical path and the float. The float, we have two types of float. We have the total float and the free float. Float, we have two of them. One is called total float, which we call it TF, and a free float. FF. Free float. The free float is between activities. Between activities. And I have an equation in the book. It shows how to calculate the free float. The total float is what? And this is what I need you to calculate. Show it to me. Either horizontally or vertical. Show it both ways. If this is the early start, early finish, late start, late finish. This is the total float is this minus this or this minus this. So the total float, TF, and they should be the same, but should give me the same answer, is late finish minus early finish. Or the total float is equal to late start minus early start. I put it in my book in a diagram, maybe easy to remember, and I hope that here it is. In both cases, I try to make life easy for you. So here it is, late finish minus early finish. This will give you the total float, this minus here. Or let's start minus, and this is a forward pass, and this is a backward. If this is the horizontal, if it is vertical, this is NCEES. Where early start, early finish, this forward. The other one is backward. To get the total float, it is late start minus early start. Exactly like this. Late finish minus early finish. Here it is. This minus this will give you the total float. This minus this will give you total float. So this is the NCEES orientation, which is the vertical, and this is the horizontal one. We need to be ready for both because it does not make any difference. The concept is the concept. So going back to the problem, and I will apply this right now because I am in CWS. So I take this minus this. Let me use green right now. Hopefully I can find the green. Here we go. So if you take this minus this, 10 minus 10 will give you 0. 13 minus 13 will give you 0. 6 minus 6 will be 0. 10 minus 10 will give you 0. 13 minus 11 will give you 2. 11 minus 10 will give you 2. These are the total float. And 10 minus 6 will give you 4. 11 minus 7 will give you 4. You should get the same answer, by the way. The float, the total float. This minus this will give you 2. And this minus this will give you also 2. And this minus this will give you 0. And this minus this will give you 0. And this minus this will give you 1. And this minus this will give you 1. And this minus this will give you 0. And this minus this will give you 0. Excuse me, it seems that I'm talking too much. The allergy is. Do you remember we have, it's called critical path, CB? What is the critical path? Critical path is the path that it has 0 or minimum float. The critical path is the path that does have 0 or minimum float. And always the critical path is the longest path, by the way. It's not the shortest, or it's not the smallest. Okay, I'm looking for something here very quick. So the CB, the critical path, is the path that has 0 or minimum float. I have some definitions here. Normally I included. It is in the textbook itself. Let me show it you in the textbook itself. So already we covered this in under means and methods, I believe. Project planning, and the critical path is defined as a path connecting all activities that has minimum or 0 float. The critical path is the longest. So I needed to be aware of that. So the critical path, the CB, it is a path that connecting all activities with 0 or minimum float. Which we know this definition. Let me write it down here as a reminder. So the critical path, the CB, it is a critical path, and this is a path connecting all activities, the path connecting all activities that has zero or minimum float. And the critical path is the longest, path. I need you to be aware of these two definitions. I wrote them here. So if you look to this, you will find that the critical path is, we'll start with this has a 0 and this has a 0, but I have to go through C. So this A to C, and from C I will go to F, and from F I will go to H. And I'm sure that you're going to ask in just a minute another question. This is A, C, F, and H. A, C, F, H. Let's look to the duration. A, it does have 3 days. C has 2 days. And F, it does have 4 days. And finally 3. So if you look to this, you'll find that it is 2 and 3 is 5. 5 and 4 is 9. 9 and 3 is 12. Did I correct? Did I miss any? This is 3, and this is 2, and this is 4, and this is 3. Okay. But somebody may say that, oh, we have a 0 here also. Oh, no, this is 1, sorry. Why did I put 0 here? 2 minus 1 is 0. This way. I said this is 1, not 0. I thought because sometimes we have a set, we have 2 critical paths, by the way. Sometimes, okay. No, but this is 1. I thought this is 0 also, but so I have only 1 critical path, which is this one here. So the question is, and when I scan this, I will send it to you. Please look at it, and I need you to absorb it. I need you to absorb it very well, especially for construction PM. And if you absorb it, very well, I believe you will be able to solve any critical path, especially for the AM. The whole story is a lag. And is asking, based on this, after all this work, which of the following statements is true? Activity E, by the way, is not in the critical path. Activity E, the critical path is like this. Activity E will have no impact on the start of any other activity. Okay. Activity E will delay the start of activity G by 1 day, but will not delay the project completion. Activity E has 4 days, by the way, lag. Float, total float. It has 4 days. So it could be delayed for 4 days without affecting anything on G. will delay G by 1 day? No. Activity E will delay the start of activity G by 2 days? No. And the activity E will delay the completion of the job by 2 days? No. Activity E, it has 4 days total float, can be delayed 4 days without affecting anything, without finishing the job. So this is not correct. This is not correct. He said which one is true. The second statement is not correct. This is not correct. The activity E has no impact on the start of any other activity. This is the correct answer, and this is the answer A. So the correct answer here is answer A. That the activity E, the same problem could be given to you and ask you what is the critical path. This is another problem. What is the critical path? This is a critical path. A, C, F, H. This is a critical path. Critical path. I think I have the same problem, but instead of giving you which of the following is true, it will tell you what. It can give you another question that activity E, how many days can be delayed without affecting the completion of the job? Could be delayed up to 4 days, because what is the total float? Total float, the total float, the TF, is the amount of time that activity can be delayed without affecting the delivery of the job. And this is given also, by the way, in all my books, and you know where it is. Okay, so at least to save time. So I need you to be aware of this, and this is a very good problem. Okay, another kind of problems I need to go over it, which the two problems before I loading are very important. How to calculate the load for the construction BM. And there is a problem in the NCEES similar to this, or this could be the same problem. Problem number 23. Load calculations. Load calculations. Can we take only just 5 minutes break, please? Just I need to wash my face and come back very quick. Can we take just 5 minutes only? 3:20, 3:25. I'll be back. Thank you. Okay, thank you. So loading or loads calculation, load or loads calculations there are two methods could be done. Two methods could be used. Either the approximate, which is the average in the, it's called the tributary area method, tributary area, or the exact structural analysis. Exact structural analysis. For a tributary area, we take what will be the area that will be the responsibility of a specific column or a specific member, and we say that the area, for example, if I have two columns supporting this, this slab, I can say, okay, each column, tributary area, take from here to here and take the average in the area here. So this is the area that will be the responsibility of this column, and this is the area of the other column. And in this case, they will carry the same amount. But here, for this one here, we have, he's asking what is the column and or the shore B2. Shore means a column. Shore is a column. Vertical column. This is a shore. Came from a shoring system. And these columns, they have stringers, and the stringers are carrying what is known as joists, and the joists supporting the plywood, and the plywood will support the concrete, the 6-inch slab, concrete slab. So there is a concrete slab here. He's talking about the shore B2. So this is ABC, this is a line B, and this is a 2. So I have a column here. And you know, we have a column here at the end. And we have a column here, which is along the B3 and B4 here. So there are 4 columns, 1, 2, 3, 4, along the line A or the line B or the line C. But he would like to get B2, okay, which is this column here. How much the load? Where he said that the formwork shown has a live load of 40 pounds per square foot. The people who are putting the concrete here and the equipment and so on. Joists are single span, simply supported. Joists are single supported, single span, simply supported. Stringers are 2 span continuous. Must consider continuity. What does it mean? What does this mean to you? As if you do have a continuous beam means a beam extend over more than one column. I have a column here, or a support here, and a support here, and a support here. Could be a roller, could be a hinge. So this is a continuous. So if this load is given as W, I can get the reactions from the steel manual tables, or my book, it has cases, and also the construction book has a table. My construction book also, either the AM. This is called continuous. We could have a different scenario. that we could have this as two simply supported beam. One like this, and let me put the middle column like this, or middle support like this. And the other beam will be like this. There is a gap between them. So this is not continuous. This, each beam, it's like a simply supported beam, and there is a small gap between them. It's much easier to analyze. The continuous one, a little bit harder to analyze, but nowadays with computers, we have no problem with that. So using the structural analysis, if you go back to the problem, if I look to this line B here, I have 4 columns. I have a stringer continuous. This is a continuous. Here it is. It is over this and over this continuous. But the joist, as you see, there is a vertical line. Here it is, this vertical line and this vertical line, this little tiny line here, indicate that the joists are not continuous. They are supported, okay, on the stringers as they're not continuous. So if I look to this side here, look from this direction, this column here, it does have this width between this, and this width will be like this. This is the area I'm going to take it out, and I'm going to draw as a continuous. So I have a column here, and a column here, and a column here. This is A2, and this is B2, and this is C2. And I need to get this load here as a distributed load. If I can get this load, W, I can get the reaction so easy. I need to get the reaction here. This is the reaction at B2. Are you following me? So let's do that. So how can I get W? W, first of all, we know that this is 3 feet and 3 feet and 3 feet. That means that this column has 1.5 feet from here and 1.5 feet. That means that this is 3 feet. The tributary width. So a 3 feet times 40 pounds per square foot, this will give me 120 BLF. This, the 120 is 40 pound per square foot times 3 feet. £120 per linear foot. So I get rid of this load here. But I need for the concrete. It is a 6-inch slab. Thickness is a 6-inch. And it is 150 pounds per cubic foot. I need it also to get it as a pound per linear foot. So plus the 6 inches divided by 12 inches per foot. times 150 pound per cubic foot. This is the density of the concrete times the width. I have 3 feet here. So if you add this to 120, so it is 6 over 12, which is 1/2 foot, and 150 times 3 times, and 120 plus. So I got a 345 BLF, pound per linear foot. And this is the most difficult part. If you are able to understand that, how to convert the given loads into like a beam, in this case, a continuous beam, carrying a distributed load W, and this W is equal to 345 pound per linear foot. How to find the reaction? Oh, piece of cake. This is aesthetically indeterminate, by the way. You cannot solve it easily during the exam because you have no time. So this is aesthetically indeterminate. There are 2 ways to go to the steel manual tables, or I provided you here with tables from the ACI, the SB4. They have tables. Here it is in my book. This is a 2 equal span. Each one, in our case, by the way, I should span. This is 5 and 5. So this is 5 feet and this is 5 feet given here. It's 2-span structure equal. So the reaction at the middle, R sub B, is equal 1.25 WL. So this reaction here is equal to 1.25 WL, where this is L and this is L, not the entire length, from center to center and from center to center. So in this case, after that became piece of cake. Since I calculated W and I went to this from the SB4. SB4, as you know, one of the publications. Let me see if I have it here or I have it. I have SB4 is this is the other one is at home, is a formwork for concrete. So it's still the same, no change in structure analysis. It's still the same tables that we use it as far as the loading, and because it came from the steel, or it came from structure analysis, not the steel manual only, came from structure analysis. So basically the beams and moments and all these things are still the same. Here it is, still the same. Here it is. Okay, so the formulas and all these things still the same, and nobody will ask you to derive these equations. Basically, we are using the beam formulas, okay, applicable for formwork design, 2-span or cantilever or 1-span or all these things. Okay, so they are available, and already I provided to you in my book. So in this case, the reaction right now is equal 1.25. W I calculate to be what? 345. Unless I missed something. Those of you who are with me here, try to see if I miss anything. 345. And L is 5 feet. So in this case, let us see if we are getting an answer to match this or not. Um, 1.25 enter, 345 times 5 times, I get 2156.25 pounds. So it is 1.25 enter. Did I calculate this correctly? Yes. It is 0.5 enter 150 times 3 times 225 and 120 plus. So it is 345. That's correct. This is the sum of these two. This plus this. And I put it here, and L is equal 5. That's correct. So the answer is B as in boy. Any question about that? This is the exact solution, by the way. This is the exact solution. Exact solution. If you are looking for an approximate solution, let me show it to you, just in case. He will not really, obviously, always will look for the exact solution. If you look to this, I said that this column here is going to take half of the width from here to here and from here to here, which is 1.5 feet, 1.5 feet. But also is going to take 1/2 of the width from here to here, which is 2.5 feet, 2.5 feet. So this column here, which is B2, this is B2, is going to be responsible for a tributary area like this. From here to here is 3 feet, the one we used before, 1.5 foot from each side. And from here to here is 5 feet, 2.5 and 2.5. So this is the area, if I use tributary area. So the total area is equal 5 feet times 3 feet, which is 15 feet square. And in this case, I can get the load like this. Load, or basically the reaction at B2, I have a uniform load, life load of 40 pound per square foot. And the concrete, I have 6 inches divided by 12 inches per foot times 150 pound per cubic foot. Units are very important. So this will give you 75 pound per square foot. So I have the load right now is equal to the 75 pound per square foot plus the 40 pound per square foot all this multiplied by the area, which is 15 square foot. 15. So in this case, we have what? We have 75 plus 40, and you multiply this by 15, give you 1725 pounds. Compared to exact versus the 2,156 pound. Obviously, this is the exact. This is the exact solution, because based on structure analysis. This based on the tributary area. but I'm just explaining just in case if you hear the term a tributary area, and we do this also. Okay, so this problem also, I will scan it and send it to you like this. At least you can look to my solution and go over it if you have any. The other problem I would like to go over it, and there are many good problems here, many good problems. The benefit cost ratio. A problem number, they expect this for the AM and for the BM also. The benefit cost ratio. Engineering economics, very easy subject, and I know you cover this in the EIT or the FE as they call it. You may forget it, but try to go back again and try to refresh your memory about it, and I will be glad to help you. So the benefit cost ratio is a ratio between the benefit and the cost, or the benefit cost ratio, or the benefits and all the costs. And we divide them. If this ratio is greater than 1, that's good news. Should be greater than or equal for local and federal government and so on. They are not in the market to make business, state and federal and cities and counties. So they can live with the benefit cost ratio equals 1. But for a private business, obviously he must have benefits, more benefits than the cost. Otherwise he will close the business. Two things I needed to be aware of. Number one, so the benefit cost ratio is a way to evaluate alternatives. And when we do the benefit cost ratio, I highly recommend you to draw cash flow diagram, CFD, cash flow diagram. This will make your life easy now, and when you go to the actual exam in October 23rd, I need you to prepare yourself as if the exam will not be postponed again, will not be cancelled again or postponed again. That's it. October 23rd, 2020. Okay, this is your opportunity. I need you to be ready. And if you remember the statement I mentioned many times, and it also included in the email I sent it this morning, the statement by Benjamin Franklin. They remember that? They remember that by failing to prepare, comma, you are by failing, you are preparing to fail. By failing to prepare, you are preparing to fail. This is Benjamin Franklin, not Shaheen Mansour, by the way. Not the Egyptian Professor Shaheen Mansour. No. Okay. I think Ray, he's the one who sent an email to me. I said that you mentioned the Egyptian more than once in your discussion. Are you Egyptian? I told him yes. Did you see or did you hear the song Walk Like an Egyptian? There is an old song. I don't know if he with us today or not. Maybe tomorrow, transportation. Walk Like an Egyptian. I told him go and search it on or Google it and walk like an Egyptian. And if I walk in front of you, you'll tell, oh yeah, you walk like an Egyptian. Okay, now. So I know you are tired, and that's why I throw this in order to wake you up. So I try to draw the cash flow diagram. Try to prepare yourself very well, such that this coming exam, October 23rd, is that's it. You ace it, and no more exams and no more money. If you'd like to give money, give it away to donate, okay, to the people who are impacted by the COVID, okay? So you can give a donation, no problem. Okay, but for the purpose of the exam, that's it. So cash flow diagram is very important. The other thing which is very important, when we are doing the benefit cost ratio analysis, we have to use either a present worth over a present worth, which is using B, or we are using annual over annual, or a future over future. Mean that the present worth of the benefits over the present worth of the costs, or the annual. Sometimes we write this as the equivalent uniform annual cost, and this is the equivalent uniform annual cost. And this is the present worth, a present worth, and this is the present worth, and this is a future, and this is a future. Each one has advantage and disadvantage, and some limitations are imposed. But if the life is the same, or the life of the assets or the life of the alternatives are the same, it does not make any difference. And this is what I'm expecting. Let us go over this problem, and I'm sure that you are going to come and ask me tons of questions. Okay? And I will do my best. As I told you, I'm short of one period with you guys, but I will do my best to see what, because I'm jumping, okay? So I have 419 for construction, coming Sunday. 419 for transportation. Okay. Here there is no, okay, for 411 today, and 418. Oh yeah, I still have one more weekend, and after that I will jump from April. I will go until June. Okay, because during this time I will be fasting, so it will be hard for me to, but I will do my best to to add one more period before we start over again. So the what, like the Egyptian, okay, the Egyptian, okay, like the, okay, yeah, okay. I don't know, my friend, is just okay, an old song. You can search it and you'll okay. So let us go to this benefit cost ratio. So we have the city of Fresno must make determination about the feasibility of repairing a bridge. The estimated useful life of the bridge is 40 years. The minimum attractive rate of return, the MARR, minimum attractive rate of return, MARR, this is another abbreviation also, minimum attractive rate of return, Simply in our case, this interest rate is 18%. The costs are given here. So the initial cost for the existing and the repair. So I have two alternatives, either to keep the bridge as is, which I call it existing. Okay. So the existing, I have cash flow diagram. At 0 time, I have 0. But for the first 20 years, I have a repair cost of $10,000. Okay. All the costs here in thousands, by the way. So it is 10,000 for the first 20 years, sorry. And from 20 to 40, it will go up to 15. So I have here starting 1, it is 10 times 10 to the power 3. And year 21, all the way to 40, the cost will go up to be 15. So every year, this is how much it costs, and this is 40. So this is 15 times 10 to the power 3. This is the cash flow diagram of the existing. I still have one more thing, which is salvage value at the end. It has a salvage value which is called SN, is equal to 4 times 10 to the power 3, 4,000. And this is 40 years, this is N. This is the cash flow diagram for the existing. If you draw the cash flow diagram for the repair option, let me draw it here next to it. And it's very, very important to draw cash flow diagram correctly. At time 0, I have 80,000 first cost. And year 20 and year 40, here I have only $2,000 for the cost of the repair or the maintenance. $2,000. And after that becomes 3,000 from year 21 all the way to 40. I'm trying to make it a little bit bigger here. So this is 3,000. And at the end, we have a salvage value of 15,000. SN is equal to 15,000. 10 to the power 3. So this is for the repair. So it's asking what is the benefit over cost for this. One more statement I should add here, and let me put it in a different color here, at least you will remember it. And then auto. I need you to remember one important thing for the benefit cost ratio is about the salvage value. Salvage value or residual value? Salvage value or sometimes we call it residual value, which is the value of the asset after the expected life. After we reach the life, you have a car, you use it for 20 years and you sold it, the price you are getting is called salvage value. I have a piece of equipment as a contractor, I'm using this piece of equipment 10, 15 years, a tractor or excavator or any kind of construction equipment. After I decided to get rid of it, for whatever reason or reasons, this is called a salvage value. Salvage value or residual value is not a benefit. BENEFIT, but a reduction of cost. Something very, very important. But and all this written in my books. Every statement I write here, by the way, today, all my books, it has all these things somewhere. Can show it to you. Okay. So this is the case here. So let's go to and finish this so we can take a break for about 10-15 minutes after we finish the class today and you start to study because you have plenty of time. I think October is the golden opportunity for all of you who are shelter in house or shelter in home. Excuse me. Who cannot go to the movie, go to the park, go picnic, go visit. We are locked in our houses, okay? Except here I'm coming to the office. My office is about 5 minutes away from my house. So I put the mask and I wear gloves and I spray my body with some kind of spray and walk because the equipment I have at home is not, or to take the equipment to set it up at home, I would think about that, but I decided no, I will come to the office because it has all my references, all the books and all the stuff here. I'm not going to carry everything to house. So I take the risk still too much risk when you go out. Every time you go out, there is a risk. But I am taking the risk. I'm trying to help you guys. Hopefully that I will not be infected or not get sick. This is why I'm always saying, please pray for me. I pray for you too. Okay. So what are the benefits? The benefits here, I used to spend 10,000 for repair. I'm spending only 2,000. So there is 8,000 difference. I used to spend 15,000 here, but I'm spending only 3,000 here. So I have a benefit. But this doesn't come for free. I have a cost here. So the cost is 80,000. So I'm going to use present worth over present worth, B over B. I convert everything to present. And let me write it, and I'm sure that you are going to come and ask me next time how we did that. So the first, the benefits, I have 8,000 here, but the 8,000 over 20 years only. There are more than one way to solve this problem, but this is, I'm going to show you one way. So I have 8,000, which is the difference between 10 and 2, 8, and this is an A. I need to get it as a P. So I will say that it is B over A. I can take the 8,000 all the way, by the way. I can take the 8,000 all the way up to 40 years. So it is 8% and 40 years. A plus. I have here 15 and I have 3. So there is a 12 here. But I took 8 all the way. So this is right now with 3 and 15. The difference is 12. But I took 8 all of them. So I still have only 4 left here. Okay. So I have 4,000. And this, I'm going to convert this. This is an A. I can convert it as a B. So it is B over A for 8% and 20 years. And there's the second one, it is B over F of 8 and 20. And I'm sure that you're going to ask me about this next time. I convert it as an B first, and the B with here is respect F. Over the cost. Cost, I have 80,000 already, 80. I'm not putting the 1,000. Minus. I have here 4 and I have 15 here. So 4 and 15, difference is 11. And this is an F. I need to get it to B. So I say that it is B over F for 8% and N is equal 40. I will get the factors very quick. Go to the interest tables in my books or any other books available in the market. My books has all the interest tables. Sorry, the interest tables, not the all. The interest table that I believe that you need. Okay. Because there are some books available in the market. They have only interest tables. Let me see if I can get them very quick. Normally I keep them sometimes small size, sometimes big size, whatever the. And I will go for interest of 8%. Yeah, wait for me, my friend. I will answer your question. Some of you have a question. I have no problem. I will. So I will go with the 8%. Here is the interest tables that all of you would be familiar with. I put it in a form of tables and columns and rows, and yeah, the tables I put it in a column. So in this case, I have 8 times B over A, B over A for 40, and 8%, and 40 is 11.9246 plus 4, B over A also, but for 20 only. So this is 9.8181, and I'm going to multiply it by B over F. P over F for 20 years, B over F for 20. Make sure that I'm copying this correctly, hopefully. 0.2145. Check these values. Divided by 80 minus 11 P over F for 40 years. It is 0.0460. If you do this math, let us see if we're going to come up with a number that will match one of these numbers here. Did I miss anything? Did I forget anything? Let me see. Because normally I solve a problem with you. I have the solution somewhere, but normally I don't look to my solutions. Normally, I do my best to, so at least you can be with me. And 8 enter 11.9246 times, and 4 enter 9.8181 times, 0.2145 times, and plus. So this is 103.82. Hopefully I didn't do any mistake. I will repeat it again one more time. And the 11 enter 0.0460 enter, and 11 times, and 80 minus, so it is 79.49. If you do this and you multiply it by the 103.82 times, I got about 1.306, which is 1.3. Let me do the numerator one more time very quick, just to make sure that it is 0.2145 enter, 9.8181 times, 4 times, and 8 enter, 11.9246 times plus, that's correct, 103.82, and 79.49 divided. I assume this is correct, and the answer is 1.3, which is a benefit cost ratio. Okay, so I will make copies and try to scan these things tonight. Hopefully I can, because I'm really tired. But if I'm not able to do it today or tomorrow also is a busy day for me. Tomorrow I have a transportation, I believe, in the morning, and I have seismic. Seismic, I made it free also, by the way. Seismic, I made it free. I send an email, I believe, or maybe somebody, one of my assistant or helper, they send an email. So this is the same ID. So if you enrolled once, so you are getting notification from the computer for all these classes, the AM and transportation and construction, and the seismic also. The seismic here, okay, let me see, I think I said that because everybody is sitting home, let me help everybody as much as I can. I'm using my own seismic books. This is a 50th edition. I used to have 5 books, but this time I condensed it to 2 only. I still have the other 3 books available. But basically, very interesting course. So tomorrow is a 412 from 1 to 5. Yeah. Okay. Good. So I try to enjoy your rest of the day, and thank you very much for coming today. I hope that you learned something. I hope all this will help you and prepare you. Let me know if there is any typo or mistake or an error, and I will be glad to correct it. And again, thank you, and stay healthy, and I will do all my best to stay healthy. Since we are healthy, we are able to meet and talk and study and pray. Thank you very much. Okay. So bye-bye, everybody. Thank you very much again. You are very welcome, my friend.